In chapter 4, we're talking about sequences and series. Here we're talking about a roof with shingles, and I've got a table of what row I'm talking about and how many shingles are in that row. So we see in row 1 there's 3, row 2 there's 4, and so on. And so we're going to use this example to describe our definition here. So a sequence is a list of numbers in a particular order. If I was looking at this, my sequence for the number of shingles would be 3, then there's 4, 5, 6, 7, 8, 9. So we see that each row we add one more shingle to the row. The term would tell is the name given to each number in a sequence. So this would be the row. So if I'm asking how many shingles are in row 3, then I'm asking for term 3. So as an example here, term 1 is 3. Term 5 is 7. So here the term in this example only, is the row. A sub n is a short way of describing a certain term. So like I said right here, A1 is 3. So this is how I would describe my term. If I want term 5, I would ask for A5, and then you would tell me there are 7 shingles in row 5. And recursive formulas use the previous term. Use the previous term to find the next one. So, for example, we always start by saying what our first term is, and then we write a rule to find the next one. A sub n could mean next. So the term you're looking for, we see that each row you just add one to the one before. So to find row 3, we just add 1 to row 2. To find row 6, we just added 1 to row 5. So we're taking the term before it. So if a sub n is the term I'm looking for, then a sub n minus 1 is the term 1 before it, and we're just adding 1 to that number. So this would be the rule for the example that we have. In example 1, they've written a rule. This is not recursive because you don't see n minus 1 anywhere. This is just a general rule for describing the sequence. And if we want the first 5 terms, we're just plugging in 1, 2, 3, 4, and 5 into the rule. So term 1, we would plug 1 into the rule, and I end up getting 1/3. Then I look for term 2. I plug 2 in for the n values. And so I'm getting 2/4, which is 1/2. Then I plug in 3 to find the third term and for the n values. Here I'm getting 3/5. A4, you plug in 4. Here I'm getting 4/6, which would reduce down to 2/3. And then A5, plug in 5, and I'm getting 5/7. And so those are the first 5 terms of the sequence described by that rule. This next one is a little more difficult. We're talking about exponents here. So A1, I would plug in 1 in for the n. And so here, let's do this in 2 steps. I have -1 squared, and then 1 squared is 1. So the -1 is being squared, so the negative goes away, and then we have 1, so we get +1 for A1. A2, we're going to plug in 2 for the n value. So I've got 2 squared, which is 4, and I've got -1 to the third. And when you have a negative to an odd exponent, that keeps the negative, so it'll be -4. A3, you plug in 3 for the n values. And here I'm getting -1 to the fourth, and then 3 squared is 9. And so the even exponent is getting rid of my negative and making it positive, so I've got positive 9. A 4, you plug in 4, and so I have negative 1 to the 5th, and then 4 squared is 16, so here I'm getting negative 16. And then a 5, negative 1, and then plug in 5. So I'm getting negative 1 to the 6th, which is going to make it positive, and then 5 squared is 25. And so here I'm getting positive 25. And this rule we can see is just the perfect squares, 1, 4, 9, 16, 25, with an alternating negative. So it's kind of a complicated rule, but that is what it did. And then if you want to pause the video and try part C on your own and see if you get it right, go ahead and do that. If not, I'm going to go ahead and do it now. So A1, you plug in 1. A2, plug in 2. A3, you plug in 3. A4, you plug in 4. A5, you plug in 5. And you should get negative 3, 0, 5, 12, and 21. All right, example 2, they give you the sequence and they want you to identify what's happening and then write down the next 3 terms in the sequence. And with fractions, I always look at what's happening with my numerators and then I look at what's happening with my denominators. So if you look at what's happening on top, if you're starting with 2 going to 4, we could be adding 2, or maybe we're multiplying by 2, or maybe we're squaring it. And then you can test to see if that works. So if it's not adding 2, because that doesn't give me 8. It's not squaring it, because 4 squared is 16, not 8. Multiplying by 2 looks like what we're doing. So on top, it looks like we're multiplying by 2 each time. And on the bottom, that could be 3 squared, but that's not squared. That could be plus 6, but that's not plus 6. It could be times 3, and that is what's happening. We're multiplying by 3. So if I get my next 3 terms, I'm just going to multiply 16 by 2 and 81 times 3. And then multiply the top by 2 again, and the bottom by 3. And the top multiply by 2, and the bottom multiply by 3. So those would be my next 3 terms. If we look at B, it looks like we're going up 1 each time. So the next number will be 6, and then 7, and then 8. But we also notice that the negative alternates. So it looks like the even numbers are negative and the odd numbers are positive. On C, it looks like the top is staying 1 the whole time. So the next 3 terms would be 1, 1, 1. And it looks like the denominators are going up by 2 each time. So it'd be 12, 14, 16. And it also looks like the negative is alternating. So if 1/10 was positive, the next one's negative, positive, negative. In example 3, it's talking about the recursive sequence again. So if there's a little subscript, that's telling you what term you're talking about. So if I'm looking for my nth term, I'm adding 3 to the term 1 before it, is what this says. The nth term, the term you're looking for, is 3 plus the 1 before it. So for example, if I'm looking for A2, then I'm making my n 2. So that would be 3 plus A sub 2 minus 1, if I plug 2 in. And so that means 3 plus A1, because 2 minus 1 is 1 in the subscript, and A1 we know is 2. So that's saying 3 plus 2, which is 5. So what we did, n minus 1 just means the one right before it. So what we did was 3 plus the number before, which was 2. 3 plus 2 is 5. So to get A3, it'll be 3 plus the answer right before it, so 3 plus 5. And then A4 will be 3 plus the 1 before it, which was 8. So we get 11. And A5 is 3 plus the answer 1 before it, so 3 plus 11 is 14. So you don't always have to do all this work if you understand what the notation means. But if you need to do all the work, then do all the work. So here, this is the term I'm looking for is 4 minus 1 term before it. So A sub 2 will be 4 minus A sub 1 because 2 minus 1 is A little 1. And A little 1 is 3. So 4 minus 3 is what I plug in. So A3 will be 4 minus, if I plug in a little 3, this is going to give me A2. And A2 is the value 1. So 4 minus 1 gives me 3. A4 will be 4 minus A sub 3, which was 3. We get 1 again. A5 is 4 minus A sub 4, which was 1. We get 3 again. So this is a cool sequence. It just goes 1, 3, 1, 3, 1, 3. So this one's a little different. A2, you plug in the 2 for n, and then plus 3, and then let's go ahead and write it in. If I plug in a 2 there, then I get A1. So that'd be 2 plus 3 times A1 was negative 2. I'm getting 2 minus 6, so negative 4. A3, you plug in 3. You plug in 3 for your A, and you get A2. A2 was just negative 4, so it's 3. Oh, I forgot my 3 on this. 3 plus 3 times negative 4. And so here I'm getting negative 9. And so we see what's happening here is we're taking the number and then 3 plus 3 times the 1 right before it. So this one's going to be negative 23. And then I've got a 5 is 5 plus 3 times the answer before it. And so that is recursive.